What if the most terrifying object in the universe had a sound? A sound created by matter being ripped apart and dragged toward a point where nothing, not even light, can escape. Before we uncover what you're about to hear, like this video, share it with your friends, and subscribe to Stella Science for more mind-blowing space content. Now, turn up your volume and get ready to hear the haunting sounds of a black hole feeding. A black hole begins its feeding process when surrounding matter gets caught in its enormous gravitational influence. Gas, dust, plasma, and sometimes entire stars can be pulled toward the black hole. But they don't simply fall straight in. Instead, much of this material begins orbiting at incredible speeds, forming a massive structure known as an accretion disk. As the material spirals inward, particles collide with one another and experience extreme friction and compression, causing the disk to become incredibly hot and release enormous amounts of radiation. The closer the material gets to the black hole, the more extreme everything becomes. Gravity becomes stronger, orbital speeds increase dramatically, and space itself is heavily affected by the black hole's immense mass. Powerful magnetic fields can also develop around the accretion disk, sometimes helping launch enormous jets of high-energy particles far into space. But here's where things become even more fascinating. Although we cannot place a microphone next to a black hole and record its feeding process, scientists can take measurements and astronomical data from these violent environments and transform them into sound. This process is known as sonification. Different patterns in brightness, intensity, frequency, or other scientific measurements can be mapped into sounds that humans can hear, allowing us to experience cosmic events that our senses could never normally detect. The result can sound haunting, strange, and almost unnatural, but it represents real information collected from the universe. As a black hole consumes more material, the surrounding environment can become increasingly violent, producing powerful changes in radiation and energy. And if a star gets too close, things can become even more extreme. The black hole's immense tidal forces can stretch and tear the star apart in an event called a tidal disruption event. The destroyed stellar material can then form a rapidly rotating disk around the black hole, releasing enormous amounts of energy that can travel across space for millions or even billions of years before reaching our telescopes. And while these events may sound like something from a science fiction movie, they are based on real observations and physics. The terrifying sounds associated with black holes are not, literally, the sound waves of a black hole screaming through space. Instead, they are scientific data translated into audio, giving us a completely different way to experience one of the most extreme phenomena in the cosmos.